According to Earth Science Western Australia, 75% of today's fastest growing careers require STEM skills, and 82% of today's employees say that they value STEM skills even if they are not required for the job. STEM also unlocks one's potential to earn a higher salary and become more employable. With all these reasons, countries around the world are pushing for STEM education for all students, including those with disabilities. Good morning, everyone. I am Ryan Operario. I'm a resource teacher for the blind and visually impaired at Zapatera National High School, Division of Cebu City. I am also a visually impaired myself, and today I am going to share with you the topic access to STEM for students with visual impairment through technology. One of the stumbling blocks in the ability of blind and visually impaired students to pursue STEM careers is the access to mathematics. Mathematical concepts are generally taught and presented spatially and visually. Hence, it is imperative for educators to adapt and modify instructional materials and teaching tools. In addition, blind and visually impaired students should also be equipped with the knowledge and skills in the use of assistive devices and technologies in learning these concepts. Some of the assistive devices and technologies that have been widely used by blind and visually impaired students are the following. Beginning with the low-tech ones, we have the Cranmer abacus, the Taylor slate, and the cube rhythm. These are devices that can aid in calculations, but take note these are not calculators. In terms of reading and writing math contents, Slate and Stylus and Perkins Braille writers are old yet reliable devices and technologies that blind and visually impaired students use. Another set of low-tech but reliable assistive devices and learning aids are talking basic calculators, geometric sets that include a compass, special protractor, ruler, and special triangles with tactile markings. With the technology boom in the recent years, hundreds of assistive technologies have been produced that can aid in the learning of math concepts to students who are blind and visually impaired. Some of these are the Braille note takers, Braille displays, and talking scientific calculators. Another group of high-tech assistive technologies are Braille printers, swell machines, and other related technologies that are very helpful in producing learning materials such as tactile graphics and math Braille text. In the past few years, 3D printing technology has become an essential component in STEM education. Blind and visually impaired learners are provided with accurate and meaningful tactile experiences through 3D models. To give you a glimpse on how math assistive technology works and helps blind and visually impaired students, I'm going to demonstrate to you a free and web-based math application called Desmos. Desmos is a powerful expression evaluator and also a graphing calculator. Aside from being a web-based application, it is also available for smartphones. Stop recording. To jumpstart this demonstration, I'm going to open a browser, particularly Google Chrome. On the address bar, I'm going to type desmos.com. That's desmos.com. On your screen is the homepage of Desmos. Now, Desmos has several features, but in the interest of time and for the purpose of this demonstration, I'm just going to zoom in on the graphing calculator feature of Desmos. I'm going to go to the math tools by pressing down arrow.
Landmark and link learn more. Navigation landmark collapsed with math tools. Expanded. List with 7 items visited link graphing calculator.
The first item here, 1 out of 7 is the graphing calculator. I'm going to activate this by pressing enter.
Graphic. Desmos graphic.
Now, once the graphing calculator page is loaded, the active field is the expression 1 field. Expression fields in this graphing calculator are the areas where we can input expressions and also equations. Now, for the first part, I'm going to show you that the graphing calculator feature of Desmos is also a powerful expression evaluator. I'm going to input an expression.
Left parenthesis, right 8, 1. 81 minus 3, 8. Left parenthesis, 38, right parenthesis.
So this is open parenthesis, 81 minus 38 minus
left parenthesis, 81 minus negative 4. Left 7. Left parenthesis, 47 plus.
Negative 47 plus 39.
39, right parenthesis.
And to check, I'm going to go to the beginning of this expression by pressing the home key.
Beginning of parenthesis block 81 minus 38.
So NVIDIA is reading 81 minus 38. That's the first part of this expression. I'm continuing to press the right arrow.
8, 1, 3, 8, after negative. Beginning of parenthesis block negative 47 plus 39.
The next part is negative 47 plus
4, 7, plus 3, 9.
39.
After left parenthesis.
To evaluate this, I just need to press the enter key.
Expression 2. Edit mode.
And I'm going to press the up arrow to check the result.
Expression 1. Left parenthesis, 81 minus 38, right parenthesis, negative left parenthesis, negative 47 plus 39, right parenthesis equals 51, edit multi-line blank.
So the answer is positive 51. Next is, I'm going to show you that this graphing calculator can also be used to solve systems of linear equations. But for this purpose, I'm just going to use two linear equations. Two linear equations having two variables. Going to type on expression 2. 3x plus 2y equals 13.
3x plus 2y. 3y equals 1. 3x plus 2y equals.
Again.
Expression 2. 3x plus 2y equals 13 as graph.
NVDA said that 3x plus 2y equals 13. That equation has a graph. So Desmos automatically graphs or translates this equation into graph, and I think that can be viewed on the right side of the screen for low vision users and sighted users. Next is I'm going to type another linear equation, and that would be on expression 3. This time I'm going to type 7x minus 5y equals negative 18.
X. 7x minus 5y. 7x minus 5y plus 5y equals 7x negative 1, 8. 7x minus 5y equals negative 18 as graph.
Same thing. After reading the equation, NVDA said that this equation has a graph. And these two equations with graphs can be traced. And to do that, there's a hotkey that's Alt plus T. So I'm going to trace this graph.
audio trace on. Use arrow keys to navigate. To hear the graph, press H. To move between expressions, press Alt plus up arrow or Alt plus down arrow. To disable audio trace, press Alt plus T expression 3 intercepted X. 0, Y, 3.6. Graph paper showing 2 graphs. Graph paper.
Now, if you're listening carefully to the screen reader, to NVDA, it gives you a summary of the key features of the two graphs. Now, it says that this is a graphing paper that has two graphs. Of course, the two graphs represent the two equations, the two linear equations. Now, to further check, to give us some hints, no, on what to expect in this graph, we can also press letter P for points of interest. So I'm going to press P.
Points of interest 3.
There are 3 points of interest. And usually these are the intersection of the two graphs. What else? You can also have the intercepts. It can be the x-intercept and also the y-intercept. Now sometimes one intercept is not or is missing because maybe the graph is not defined on some of the values of x or y. Now I can manually trace this by pressing either left or right arrow, but that will take me some time to really understand what this graph. No? So to give me a general view of what this graph is, I can press the letter H, and H will give me this feature. Okay, if you listen carefully, you would hear a sound, one that is going down, and there's that popping sound. Now let me hear that again. Okay, it's going up, that's not going down, and there's that popping sound. That popping sound can either be the intersection or the intercepts, but usually it's the intersection. And as you all know, intersection can be the solution of this system of linear equation. It can be the point where these two equations intersect, and of course they are this is that point. The values of x and y are the solution of the two equations. Okay, now this graph can further be enlarged and can also be shared to the blind or the visually impaired classmates, and even to his or her math instructor. And that can be done through the share button feature of this application. And I can do that by, first I have to exit from this trace or this trace feature by pressing the escape key. Okay, audio trace off. I'm going to press the tab key.
Hide expression button. Graph settings controls grouping. Graph settings menu.
Okay, here's the graph settings. I'm going to activate this.
Graph settings complementary landmark. Display size grouping. Display size. Large toggle button not pressed.
Okay, display size, and it says large is not yet pressed or it's not yet activated. So I'm going to activate that for
Pressed.
low vision and sighted users. Now this time it should be a bigger bigger graphs than the ones that we had earlier. I'm going to check for the minimum and maximum values of x and y. The purpose for that is for me to know if this is symmetrically graph, no? So I'm going to check. I'm just going to press the tab key.
Reverse contrast checkbox not checked. Braille mode check, grid checkbox, Cartesian grid polar grid top arrows check, axis numbers checkbox.
If you notice, these are just some of the many features of this graphing calculator. There are several controls that we can turn on and off to give us a different look and a different information of the graphs.
Minor grid lines checkbox, x-axis checkbox, add x-axis minimum, -10 edit.
Okay, the minimum value of x is negative 10.
X-axis maximum. 10 edit.
Maximum is positive 10. Going to check for y.
Y-axis and y-axis minimum. Negative 6.4.
Okay, in this case, it's negative 6. So this is not really a balanced or symmetrically drawn graph. So I'm going to change this to negative 10.
Selection 1, 0, 10. Y-axis maximum. 6.464 edit multi-lines.
Also with the maximum value of y. I'm going to make it 10.
Selection 0, 10. Y-axis.
Okay, I'm done with these settings that I have just modified. Now the purpose for that is when I'm going to share this or export this graph, it would be or it would look better, no? Or it would appear as a good picture of a graph.
Lock view link. Angle settings group degrees toggle graph settings menu graph settings complementary landmark display size reverse contrast display graph settings menu button collapsed.
So I'm going to exit from the graph settings and I'm going to look for the share button.
Zoom in button, zoom out button, restore default graph paper showing two search tabs menu button toolbar, view site information, search dead graphs, zoom in graph settings menu expression list, expression, hide expression, edit expression, undo button, add item button open graph, help menu button collapsed, share menu button collapsed.
Okay, here's the share menu and activating this.
Complementary landmark, link to this graph edit https.
I can share a link to this graph to my classmates or to my math instructor. And I can copy the link and share it. I can also print this. This can even be exported and printed in a braille printer and also in a regular ink printer. I can also export an image of this that I can submit to my math instructor.
Embed button. Desmos graphic calculator. Expression bar toolbar.
So these are just some of the many features of Desmos, particularly in the graphing calculator part.
Ops 27.